Now we're going to look at how to graph these polynomial functions based on finding the zeros and the end behavior. So we're going to look at this function here, f of x equals 5x squared times x minus 1 times x plus 2 being raised to the third. And we want to be able to first find the x-intercepts, second, be able to tell whether it touches or crosses those x-intercepts, and third, be able to find the end behavior, and then take all of that and put it into a single graph. So let's start with the x-intercepts. To find x-intercepts eventually, we're going to set the function equal to 0 and then go term by term and find what those zeros are. So here I can say that 5x squared could equal 0. I could say that x minus 1 could equal 0, but I could also say that x plus 2 to the third could equal 0. Well, in solving any of these, this first one, if I divide off the 5 and square root it, I'm going to get x equals 0. Second one, I just add the 1 over, I get x is equal to 1. And then the third one, I can get rid of the third power by taking the third root, and then subtract the 2 over, I get x equals negative 2. So then those intercepts, I could say, are at 0, 0, 1, 0, and at negative 2, 0. So anytime I want to find the zeros of a polynomial function, if it's in factored form, I can take each of those individual factors, set them equal to 0, and then solve for the zeros. Once I have those, I can start looking at one of these terms to determine if they're going to cross or bounce at that point. So if I'm looking at that power, x to the second, and x to the second graph, in general, is going to look something like that. So as it comes into that intercept at 0, 0, it should resemble this type of graph. So out of the two options here, I would say it's going to bounce or touch that intercept at 0, 0 instead of crossing over. Secondly, if I look at this next term, the x minus 1 is a linear function. So out of the two options of touching or crossing, if I approach an intercept and then follow with this same graph, we're going to cross over that x-intercept. And third, with this last one, x plus power, third powers are cubic and will look something like that. So as I approach this intercept at negative 2, I would expect to cross over that intercept as the cubic function would. Now, the intercepts and the behavior at those intercepts don't really mean anything unless we know what the total end behavior is. So if I look at f of x could be approximated by 5x squared multiplied by x multiplied by x to the third. Ignoring the shifts on the intercepts, I'm just looking at those exponents for each one of those terms. And if I combine that together, that would give me a 5, and then combining my exponents, x to the sixth. Looking at that degree of 6 tells me I have an even degree for this function. And even degree functions are either both up or both down. So I could either look like this, both sides going up, or both sides down. This one being a positive, this one being a negative. And since my coefficient is a positive 5, I would say my end behavior is going to look something like that. So on the outsides of this function, on the right and the left, both of those sides to go up. And then we can use these ideas of bouncing or crossing in between to get an idea of where that graph's going. So to pull all this together, I'm going to first plot my intercepts. I've got one intercept at negative 2, a second intercept at 0, and a third intercept at 1. Based on the end behavior that we just found, we knew that the left side of this graph are going to be going up. So it's going to look something like that. We determined at negative 2 that we were going to cross over and go to the next 0. So it looks something like that. At 0, we were going to bounce. So as I come in, I want to make sure I have a curve on that. It's not a hard corner. And then I'm going to go to the next intercept. And then at 1, we were going to cross up. This would be a rough sketch of that graph. Now, what if we want to know these coordinates are correct? Well, we can come over here and create a table and figure out what numbers to plug in. Based on where my intercepts are, I might choose a -3 because it's on the left side, a -1 because it lands in between my two intercepts, a +1/2 because it lands in between two intercepts, and a +2. And that can tell me exactly how steep each one of these sections are, or give me a little bit more definition to the graph. And I can figure out what each of these y values are by plugging those in. So whether I want to use the crossing or bouncing, or use a table to help me determine which section it goes to, either way can accurately give me an idea of where that graph goes.